Graph neural networks are a powerful class of neural network designed to process graph structured data. They have found widespread applications across various domains such as social networks, recommender system, and drug discovery. In this video, we'll provide a brief introduction to graph neural networks and demonstrate a simple example of implementing a graph neural network using the pytorch deep learning framework and the pytorch geometric library. So let's get started with understanding what a graph neural network. Basically, graph neural networks are a type of neural network designed to work with graph structured data, such as social network, chemical compounds, or protein-protein interaction network. In contrast to traditional neural networks that process data organized in a grid-like structure, example, images or text, these graph neural networks operate directly on the nodes, edges, and their associated features in a graph. The key idea behind graph neural network is to propagate information between the nodes in a graph, allowing nodes to learn from their neighbors' features. Here, the neural network updates each node's representation by aggregating information from its neighbors, typically using learnable parameters. And this process is repeated multiple times, known as message passing, to capture the complex relation between the nodes in a graph. Here, graph neural networks are particularly useful in applications such as link prediction, community detection, node classification, and graph classification. They have also shown promising results in fields like drug discovery, natural language processing, and computer vision. So to summarize this, we can say graph neural networks are neural networks that operate on graph structured data by propagating information between nodes, learning from neighbor features, and capturing complex relations within the graph. So to understand this better, let's understand it using a Python code. Now in this code, first we will install the required packages, then we will import the necessary Python modules, and finally we will load the citeseer citation network dataset using plantoid class from torched geometric dataset. And this dataset is split into train, validation, and test dataset. And then we will extract the train, validation, and test marks from this loaded dataset, and these marks indicate which nodes belong to each set. Then we will define the graph attention network classifier that inherits from nn.module. Here this graph attention network classifier consists of two parts: GAT, that is the GAT attention layer, graph attention layer, and a linear layer. Then we will print the number of nodes, edges, and classes in the citeseer dataset. And then we will instantiate this GAT classifier and move it to the specific device, that is GPU if available, else it's CPU. Then we will move the dataset to the specified device. Same, GPU if available, else it's CPU. Then we will define the loss function, cross entropy loss, and the optimizer, that is ADAM, for training the model. And then we will train the model for 100 epochs using the train mask to calculate the loss. And after each 10th epoch, you will print the loss value. Now this code basically demonstrates how to use pytorch geometric to download a citation network dataset, that is citeseer, then define a simple GET classifier and train the classifier on this dataset. And this examples provides a solid understanding point for implementing graph neural networks using pytorch geometric and learning network framework. Thank you.